All right, class, here's section 4.5, properties of logs. These are going to come really in handy when we're going to solve logarithmic equations in the next section. So, just one more time, what is a log with base 2 of 32? Well, the log with base 2 of 32, again, has to equal to the exponent to which you have to raise 2 in order to get 35, right? So that would be 5. So one more time, the log is an exponent, right? And so that's kind of what I want to leave it at, because if the log is an exponent, that means those properties of exponents somehow will have to apply back to logs. Okay, so that's what I want to go over next. Review those properties of exponents that you have learned in your algebra classes. Okay. So, what are those properties of exponents? We've learned that if we multiply numbers with the same base, they might have different exponents or not, whatever they are. When you multiply numbers with the same base, you simply add up the exponents, right? The same way, if you divide numbers with the same base, what we do with the exponents is subtract them. Okay. All right. You've also learned that if you have a product of numbers, and that whole product, again, has to be times, right? Not pluses in the middle. So if you have a product that's raised to an exponent, what you could do is you could distribute that exponent to each of the factors inside, right? And the same rule applies for division. So if you have a quotient that's raised to some exponent, what you get to do is you take that exponent and distribute it to both numerator and denominator. All right, another great property is that if you have a number that's raised to some kind of exponent and the whole thing gets raised to yet another exponent, what you get to do with those two exponents is multiply them. All right. We have a couple more, and I just want to remind you, x to the power of 0 is always equal to 1, right? And if you have a negative exponent, what that simply means is you could turn into a positive exponent by taking reciprocals, right? Now, we're not going to turn or use all these properties of exponents and turn them back into logs, just a few of them. And I will tell you in a second which ones. But we have 7 properties of exponents. Just want to remind you really quick of all of them. Now, how do these properties translate in for logs? Well, let me write them out for you. Okay, first things first, if you have a log with some kind of base b, and there's a product inside, what you get to do is you get to split that log to the two factors by adding the logs. So that really comes from this property number 1 that says if you multiply numbers, right, with the same base, what you get to do is you add up the exponent. So I'm not going to go through how to prove this. It's in your book. It's fairly easy. But if you have, again, a product inside the log, then you can split the log to the two factors by adding them. And the same way, and again, that's actually from rule number 2 right here that I put up for you. If you have inside a log a quotient, what you get to do is you get to split the log to the top minus the log of the bottom. Okay, so it's the subtraction of the two logs, or you subtract the exponents, right? And finally, only 3 rules for this. If you have inside a log a number with an exponent already, what you get to do is you throw out that exponent as a factor in front of the log. Okay. Now, where this rule really comes from, it's again actually this one from here, but you can also think about the what? An x to the power of m is really a repeated what? X times x times x, right? times x m times, yes? So what the first property says that what you can do is if you have a product inside, right, a log, you split the log into each of these factors. So how many of these common factors are you going to have? M of them, yes? So it's like adding like terms, yes? So once you add up all these terms, you get M of them. All right, so yeah. All right. Now, these are the three main rules of logs, but I'm going to give you two more, and these last two come simply from the fact that logarithms are inverses of exponents. So if you have a log with some base b, of b to some kind of power of x, in other words, the bases are the same. Again, logarithmic and exponential functions are inverses of each other, right? They undo each other, okay? And the same way, if you have a base that's raised to a log with base the same, b of x, these cancel out, undo each other, and you just get the x, okay? Now, this in a log, in a natural log form, just want to give them to you because that's going to help a lot, since again we can take exponential functions and logarithmic functions and exponential functions and turn them all into the natural log, a natural exponential function. You're going to see this a lot, okay? So it's a good visual. And I know I said this is going to be all, but just as a not necessarily a property, it's clear, right? Log with base b of 1 is just the same as anything raised to the power of 0 is equal to 1. Log with any base of 1 is always going to equal to 0, right? Because it's that 0 exponent, right? That's going to get you the 1. And I know we've practiced these here, and I just wanted to put it up. Not, again, necessarily a property, but it's also good to know right away. The log with base b of b also always equals to 1, right? Because, and not that you wouldn't have known it, but it's the power of 1, right? Or you could think about even this first property here, right? This is a b to the power of 1, right? A log with base b of b cancel out, but they're not going to get you a 0, right? They give you a 1 because it's b to the power of 1, right? So let's use these rules. And the first application is that we're going to expand and write as a single log. So both are very helpful. So sometimes we might want to take a complicated log and expand it into simpler logs. And by the way, that's how your calculators work, right? You give them a complicated log to evaluate, it breaks it up into logs. It knows how to evaluate. So here it is. We're going to use our rules to expand into simpler logs. What does that mean? So we're going to, first of all, use that property number 1 that says what? If you have a log of a product, that splits into a log of a first factor plus the log of the second factor. All right? So there you go. Already this log looks simpler than the initial one, right? It has less of it in it. Okay, what else can we do? Property number 3 says that if you have a log with some exponent inside, what you get to do is take out that exponent. And the same thing here. There you go. And it can get simpler than just having an x inside, yes? All right, let's try another one. Log, common log, by the way, if I didn't put any if I didn't put any base on it, right? That always means a base of 10. Common log of x plus 7 over x minus 1. Well, what this again, the second rule says, that's the log of the top minus the log of the bottom. And already I did something wrong, obviously on purpose here for you. And what I did wrong is this. If I see this thing here, I'm going to think it's log of 7 only, and then plus 7. And you might even be tempted to cancel out these logs and add them up, and it's a 6, but it's not true. So, same as you every time have to group terms that go together, right, just to make sure that you are using the order of operations properly, the whole x plus 7's inside the log. So, like I mentioned before, if you have a square root ever, right, it is important to say what's inside the square root. This is very different than if you just write that, right? So this is why we have to be very careful with our square roots, or any root for that matter, and extend it as far as all the terms that are supposed to fit in it. So if I do that, then we know for sure the x and the 7 are inside, right? So obviously with the log, we don't have this luxury of stretching out the log for as far as it goes. So what you definitely need to do is put parentheses around it. Now, can we split the log though anyhow? The answer is no. We don't have a property. If you look back on the first page, we don't have a property that allows us to distribute a log to a sum or a difference. So that's your answer right there. Okay. All right, let's try another one. What about log? Well, I'm just going to keep an ln, just to write less, of a squared over b to the 4th, c to the 5th. Okay, so first things first, I'm not splitting these. You have to like kind of break this in the reverse order. So the first thing I see is a big division. So we're going to split it into the log of the top minus the log of the bottom, right? Okay, then what? Now, of course, a product can be split into the log of, I should write it underneath. So I have a natural log of a squared minus natural log of b to the 4th plus natural log of c to the 5th. Okay, and again, I did something wrong on purpose. What did I do wrong on purpose? Well, I'm minusing both these, right? I'm minusing the sum, and the way it looks like here, it would look like I'm just minusing the first term. So this whole thing has to be minus the way, right? It has a minus in front of it. Yes, I've split this into a sum, but that whole sum has to be subtracted. Yes. Okay, I'm going to fix that in the next step. Alongside with it, what else can I throw out? Anything that has an exponent inside the log, we can throw that exponent up front as a factor. Minus 4 ln of b, and remember we're distributing the minus here, so minus 5 ln of c. Okay, and there you have it. So really, I could have done this in one step only, and the more practice you get, the faster you can be at it as well. If you look at it, what happens? Anything that was in the numerator, right, has to be a positive. Anything that's in the denominator is going to have a negative in front. You could even think about the properties of logs that said that what? If you have the properties of exponents said if you have a number with an exponent in the denominator, you can put it at the top, but that really was a negative exponent, right? So all these factors with this b to the 5th and b to the 4th and c to the 5th simply means they had negative exponents. They came from a b to the negative 4 at the top, right? So it's the negative 4 that we put up front. So let's try this again. Maybe faster. You can still go through all the steps, no problem. It doesn't take as long. But if you want to be super fast, that can be done just fine. Here it is. Let's try this super fast. ln of x to the 3rd, y to the 5th, over a to the 4th, b to the 10th. So the good thing is it's all a product and a quotient, right? So we're going to split the log to each of the factors, but what's going to happen? These factors in the denominator, yes, are going to have negative exponents. So really quickly, you could even do this. It's a 3 times natural log of x plus a 5 times natural log of y minus a 9 times natural log of a and minus a 10 times natural log of b. Okay, there you go. That's how fast it can go. All right. So let's step back maybe. All right, so as I said, you can do it super fast. You can take your time with it. So I'm going to take my time back. So natural log of, again, I have a quotient, so that quotient is going to split into a difference. Great. Now, this looks like it's an exponent that I can take up front. Now, this fourth root of y might look like that's it, but let me remind you that roots are nothing but exponents as well. So if you remember, what's the fourth root of y? That really is a y to the 1/4 power. So sure enough, that had an exponent as well, so we have to rewrite radicals as exponents, and then we can use that third property of logs that allows us to take exponents up front. Okay, one more, and then we'll go the other way. Here it is. ln of, again, break it up into simpler logs. ln of the square root of x to the third over x plus 2. So sure enough, what did I say? I said that these radicals, I am going to rewrite them as fractional exponents, right? Rational exponents. Okay, now as you see, that belongs to the whole thing inside the log, right? It doesn't just belong to pieces of it. So the first thing in my way, breaking this up, is this 1/2 exponent, which I'm going to have to throw out first. Okay. Now, the next thing I see is a quotient. So that's the next thing I'm going to break up. Be careful of a couple of things. Again, the 1/2 is multiplied to whatever is coming next. So whatever's coming next will have to be put in parentheses, yes? And then just here, I again be careful, the x plus 2, I have to make sure that I tell you that the whole x plus 2, and just to be safe, many people will always put parentheses around anything that's inside the log, just out of habit, right? Even though it's clear it's an ln of x to the third, so x to the third is inside, even if it's just a number. Many people, professors, will get simply in the habit of writing parentheses around anything that's ever inside the log. Okay, so one more thing. That's 1/2 times, I'll throw out the 3 outside of this log. Again, if you want. And there's that. And remember, we cannot split a log to a sum or a difference, so that has to stay as it is. Okay, so really quick, let's go the other way. And we're going to use these properties backwards to write as a single log. So instead of having it all nicely spread, we're going to tuck it back in together and write as a single log. All right, here it is. So let's try this. What is log, common log of 2 plus common log of a plus common log of 11 plus common log of b? Now, kept this simple, and as you see, it's all plus, 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 so we can write it as 1 log of, what do I do with all those insides? I multiply them. And sure enough, if there's anything you can multiply together, you should. So that's a common log of 22 AB done. And again, just to be safe, if you want, you can put it all inside the parentheses. Okay. What about this? Backwards. 2 natural log of A minus 3 natural log of B. How do I write this together? Now, I know that the difference between logs will have to be written as a quotient. However, these are not just logs. It's 2 times a log, 3 times a log, so only log minus log will be turned into one single log. However, what do we get to do with these exponents? I'm sorry, with these factors? The rule number 3 said that you can put them up as exponents. So it's kind of like exactly the opposite order, right? So remember, when we simplified these logs, like just here, right? What did we do? We threw the exponents out at the end, right? First we split it into the quotient, then we threw out the exponents. Now, we'll do this in reverse order. We'll throw out the factors up as exponents, and now a log minus a log of the same base can be written as 1 log of the quotient between those, we call them arguments, right? Whatever's inside the log. Okay. So let's try one more. I have 1/2 log with base 5 of x plus 1/3 log with base 5 of y minus 5 log with base 5 of z. So very simple. What are we going to do? I am going to first throw these coefficients up as exponents. So I'm going to get a log with base 5 of x to the 1/2 plus a log with base 5 of y to the 1/3 minus a log with base 5 of z to the 5th. Okay. What do sums turn into? Sums turn into 1 log of the product. What do quotients turn into? Quotients turn into 1 log of, I'm sorry, differences. What do differences turn into? Into a quotient of 1 log this is gonna stay at the top, right? Minus this guy gets thrown on the bottom. All right. So do we now have a single log? Remember, we wanted to write as a single log. It's a complicated log, but there's only 1 log in your answer now, right? So we definitely satisfied the conditions. If you want, you don't have to, but if you want, you can, and just for practice, by the way, I'm going to rewrite what these things mean. A 1/2 comes from a square root. You don't have to rewrite it, but I'm just showing you, again, for practice purposes, where that 1/2 exponent came from and the 1/3 exponent came from. All right. So you get the idea of playing with these logs forwards and backwards, applying the rules. It is quite a bit of fun. And as I said, it's going to help us greatly. Sometimes it helps to simplify into simpler logs. You can combine like terms, right? Cancel common factors maybe, yes, common terms, or write it as a single log. So mainly what we're going to use in the next section when we're going to solve logarithmic equations is write as a single log. So I just got a couple more for you just to use the other rules. They come from the fact that logarithm and exponential functions are inverses of each other. So how can I simplify this? Really, I can do it 2 different ways. You can think about, again, the rules that we've just done that said that what? If I have an exponent inside the log, I get to throw it out. And then what's a log with base 3 of 9, right? So what exponent do you have to raise 3 to in order to get 9? That's a 2, right? So the answer is going to be 2x. Great. I said I could solve it a different way as well. So what I'm going to do is I'm going to rewrite 9 as a power of 3, and that's 3 squared, right? And if you can think again about the rules of exponents, that told you if you have a number that's raised to a power to another power, what do you do with the 2 powers? You get to multiply them. And then we are using the rule that logarithms and exponential functions are inverses of each other as long as they have the same base, right? So they have to have the same base, then these are going to cancel out, and it's just going to leave you with 2x. Okay? All right. Yeah. So let me give you just one more. What is 2 raised to the power of log with base 2 of 5x? And that's simple, and it's straightforward. Again, an exponential and a logarithmic functions undo each other, right? So kind of the same way as what? A cube root and a cube, yes, undo each other. As long as the powers are the same, they're going to cancel out and leave you with whatever's inside, right? Same thing here. The 2 and the log with base 2 cancel out, and they're just going to leave you with 5x. Okay. All right. So have fun playing with this for homework. This is it. That was a short section.